In a previous video, we looked at how we can handle some integrals, some antiderivatives by using substitution. We'll do the same thing here, except we will evaluate definite integrals using substitution. And there is a slight modification that we're going to have to do to evaluate those, but it's a fairly straightforward one. So we'll start this the same way we started evaluating the indefinite integrals using substitution. We'll look for something here that when we take the derivative of it, that derivative is involved in the expression, and this one may or may not be obvious at first, but if we take the derivative of the tangent of x, we get secant squared of x. So we'll let u equal the tangent of x, which means that du is going to equal secant squared dx. And making our substitution, then we get the integral of 2u with respect to u. Now, everything we've done so far is the same as what we did with antiderivatives. Right now we have an indefinite integral, but we have to include our limits of integration. Now, this 0 and the pi over 3, those are x values, but since we've changed to the variable u, we can do one of two things. We can keep the x values here, and then in the end we can plug the expression for x, in this case the tangent of x, in for u, or we can change these variables right now, and we can figure out what u is going to equal when x equals 0, and we can figure out what u equals when x equals pi over 3. And we'll go ahead and do it that way. So when x is 0, if we put 0 in here for the tangent, we know that tangent of 0 is 0, and so we know that u is going to equal 0. When x is pi over 3, to evaluate tangent, we'll go ahead and draw a circle here. When x is pi over 3, the tangent of pi over 3 is going to be the square root of 3 over 1, and so we'll say that u equals the square root of 3. It's important to keep in mind that these limits here, if they are not the same variable as our variable of integration as given by the differential, we need to include the variable here. Since we've changed them to u's now, the u equals in the lower limit and the upper limit here are not necessary, but not a bad idea to put them in there since we've changed the variables, just to keep that in mind. At this point, all we have to do is evaluate this, and we can forget about the x's completely. We don't have to reintroduce the x's since we changed our limits to u's. So we get u squared evaluated from 0 to the square root of 3. And so that's going to be the square root of 3 squared minus 0 squared, which gives us an area of 3. We would get the same answer of 3 if at this point we put the tangent of x in here and we had the tangent squared of x, but then at that point we would want to use 0 and pi over 3 to evaluate that instead of square root of 3 and 0. Another example here, we'll have to use substitution. So we'll replace the denominator here with u. So we'll let u equal x squared minus 4, which means that du is going to equal 2x with respect to x, or times the differential of x. Since du equals 2x dx, we are going to need a 2 up here with the x to do the substitution. And to counteract that, we'll put a 1/2 out front. And now we can rewrite it. We get 1/2 times the integral of 1 over u. But just like the last example, these are x values, the 0 and the 1. So we have x equals 0 and x equals 1. So what we can do is we can put 0 in for x here, and 0 squared minus 4 is negative 4. We can put 1 in for x here. We get 1 squared minus 4 is negative 3. So on the u-axis, we're going from negative 4 to negative 3. At this point, all we have to do is evaluate our integral. So we get the natural log of the absolute value of u. And if you remember, we need the absolute value here so that we can handle the negatives. And evaluating this at negative 3 and negative 4, we get 1/2 times the natural log of 3 minus the natural log of 4. And it's a good practice to write natural log answers as a single natural log. Remember, this is the difference of two natural logs is the natural log of the quotient. So we get the natural log of 3 over 4, or the natural log of 3/4. And we can also take a coefficient and put it in the exponent. and so an exponent of 1/2 is going to be a square root, and in the end we get the natural log of the square root of 3 over 2. And this is the simplest answer, or the simplest way we can write this answer with the natural logs.